In multilingual question answering, one of the most persistent challenges is the language mismatch between user queries and the knowledge base. When a user asks a question in Korean or Finnish, but the relevant documents are only available in English, how do we bridge that gap without losing accuracy? Current approaches in multilingual RAG, retrieval-augmented generation, typically fall into two camps. The first translates the query into English to match the dominant language of the document collection. The second translates the retrieved documents into the user's language. Research consistently shows that document translation outperforms query translation, especially in preserving cultural nuance and word sense. But here's the catch: translating documents introduces noise. And worse, many systems attempt to fix that noise by rewriting the translations using large language models. This rewriting step, while improving fluency, comes at a steep cost: factual distortion. The model may fabricate facts, insert entities not in the original, or reframe content to better fit the query. This leads to hallucinations, where the answer appears plausible but is entirely wrong. We call this the rewriting paradox. You fix one problem, poor translation quality, by introducing another, semantic drift. So what if we could retain the original translated content, assess its quality explicitly, and let the generator decide how much to trust it, without ever altering the source? That's the core idea behind our work: quality-aware translation tagging in multilingual RAG, or QTT-RAG. QTT-RAG introduces a three-tiered quality assessment framework applied after translation. For each document translated into the query language, we use a large language model not to rewrite it, but to evaluate it across three dimensions: semantic equivalence, grammatical accuracy, and naturalness and fluency. Each dimension is scored on a 0 to 5 ELO-style scale. These scores are then attached as metadata to the passage, never changing the text itself. The generator receives the original translated content, plus these quality tags, and can now make informed decisions. For example, a high-quality translation with strong semantic fidelity and natural phrasing gets prioritized. A low-quality one, riddled with mistranslations or awkward syntax, is downweighted or handled with caution. This way, the model doesn't blindly trust every translated passage. It learns to audit its own sources. Now, why does this matter? Let's look at the evidence. We evaluated QTT-RAG on two major multilingual benchmarks, XOR-TyDi QA and MKQA, using 6 instruction-tuned LLMs ranging from 2.4 billion to 14 billion parameters. The languages spanned low-resource settings, Korean and Finnish, and a high-resource one, Chinese. The results were clear. QTT-RAG consistently outperformed both CrossRAG, which assumes translation quality is sufficient, and DKM-RAG, which relies on rewriting. On the Korean subset of XOR-TyDi, QTT-RAG improved character 3-gram recall by up to 6.8% over the baselines. In MKQA, gains ranged from 3.8% to 12.6% depending on the model. Even in Finnish, a similarly low-resource language, QTT-RAG matched or exceeded baseline performance across all models. But the real insight came from ablation studies. We compared QTT-RAG against a hard filtering strategy, where we simply removed any document scoring below 3.5 on all three criteria. At first glance, this seems like a clean solution: only keep high-quality content. But here's what we found. QTT-RAG outperformed hard filtering in every case except one. In Finnish, hard filtering even beat QTT-RAG for one model, iExpanse 8b. But in Chinese, where most documents are already in the target language, hard filtering actually hurt performance. Why? Because it discarded rare but critical cross-lingual evidence. So what's the trade-off? Hard filtering is brittle. It depends on threshold choices, and it risks losing rare but important information. QTT-RAG, by contrast, preserves all retrieved passages, even low-quality ones, and gives the generator the tools to weigh them appropriately. It's not about filtering out noise, it's about understanding it. And this is especially powerful in low-resource settings. When native language documents are scarce, like in Korean or Finnish, cross-lingual retrieval is essential. But without a way to assess translation quality, you're flying blind. QTT-RAG gives you a compass. We also analyzed failure cases from existing systems. In DKM-RAG, the rewriting module often added entities not present in the original, like inserting a death date for Gwisselboxen into a passage about rumor gotten. The generator then treated this fabricated fact as truth. In CrossRAG, translation errors were rampant. Entire sections omitted, key names misrendered. One Finnish translation of a passage about the Egyptian pyramids completely dropped the El Kuru and Nuri subsections. Another Chinese version of a song's release history misrepresented the UK chart performance and even changed the title to Western Song. These aren't edge cases. They're systemic risks of current approaches. But with QTT-RAG, such errors are flagged. The model sees the low semantic equivalence score, the poor grammatical accuracy, and the awkward fluency. It can then either skip the passage, treat it with skepticism, or use it only as a weak signal. We also explored the role of cross-lingual share, the proportion of documents that need translation. In Chinese, where only 5% of documents are non-native, gains are smaller. But in Korean, with 22.7% cross-lingual content, the benefits of quality tagging are maximized. This tells us something important. QTT-RAG is most effective when translation is both necessary and uneven. That's exactly the regime where low-resource languages live. And while we've tested it on Korean, Finnish, and Chinese, the framework is generalizable. It can be extended to any language pair, any retrieval model, any generator. Of course, there are limitations. The generator must be able to interpret the quality tags. Models with weak instruction following or short context windows may not leverage them fully. And our evaluation is still limited to a few languages. But the principle holds. Quality is not something to be assumed. It should be measured, exposed, and used. In a world where multilingual AI is no longer a luxury but a necessity, we can no longer afford to treat translation as a black box. We need systems that are not only intelligent, but self-aware. QTT-RAG is not a silver bullet, but it's a critical step toward robust, trustworthy multilingual reasoning. It shifts the paradigm from fixing translations to understanding them. And in doing so, it preserves factual integrity without sacrificing performance. If you're working on multilingual systems, if you're building RAG pipelines, or if you're just curious about how AI can better handle language diversity, this is a framework worth exploring. The code is available at github.com/hoyenm/QTT-RAG. And the paper is open access. Because the future of multilingual AI isn't just about translating words, it's about translating trust.